I had the idea for this conference when I was writing this book. That's the end of my plug, but I published this book in March last year, and it struck me that there's an awful lot of work going on in geological decarbonisation. You know, geothermal, in compressed air energy storage, in carbon capture and storage, in BECCS, biofuels and CCS. And I thought it would be worthwhile, the people that work in geological decarbonisation, to get together and to think together about the challenges that we have, the research questions that we have, and the opportunities that we have, and to try to work more as a community together, and perhaps even to develop a roadmap that recognises the common problems that we have, for example, across carbon capture and storage and across biofuels and carbon capture and storage, for example, or across geothermal. So that was the basic idea, to get together scientists in geology who are working on decarbonisation together. And it's no surprise that we are important to decarbonisation. In fact, of course, we were vital to carbonisation, if you look at it this way around. If you look at resources and geology, carbonisation, which essentially was with the Industrial Revolution, the distribution of geological materials was absolutely vital to the development of the Industrial Revolution. But of course, for decarbonisation, the same will be true as well. We will need to be able to use geological materials to decarbonise, whether that be structures that enable us to store energy at grid scale, or using heat that's under the ground to help us heat houses and decarbonise that way. So carbonisation was a geological thing, so will decarbonisation be. And that's why it's very important for us to be together. Recently, I went on a short field trip to Iron Bridge, and it was really interesting. I don't know if you've ever been there to see the wonderful steel iron bridge that was built during the early stages of the Industrial Revolution. The fact is that Iron Bridge wouldn't be there in Shropshire if you didn't have those three things nearby: iron ore, limestone, and the other things that you need. So iron ore, limestone, and coal were present in the Iron Bridge area. And that's why it happened, because you could get large amounts of materials to build that iron bridge. And I think the same will be true for decarbonisation. The places where the sorts of materials we need to decarbonise, so the geological materials, the energy, the rock types, will need to be in a certain position or a certain grouping to enable us to decarbonise properly. So this is the idea of clusters. And already in the UK, we have clusters for the northwest of England and for the northeast of England, where we're thinking about how hydrogen, the hydrogen economy, might work alongside CCS, which might work alongside other sorts of geoenergy. So just to finish off, I think it's really important that we look at geology in the round. We try to work out how we can work together to decarbonise. But just two interesting facts. I just looked at the Energy Transitions Commission's report this morning. We have to go from 36 gigatons per year today to 20 gigatons by 2040. We're also looking at possibly having as many as 11 million electric vehicles on the road by 2025, and perhaps 30 million by 2030. So this is going to need battery materials, metals for batteries, and materials for keeping those electric vehicles on the road. So we've got a lot to do, but I think we've got the right scientists in the room the next 3 days, and it would be great for us to produce a roadmap of how we might develop decarbonisation in geology. So thanks very much for coming. I'll hand over to Stuart.